Alright, so this is a diagram of a passive continental margin, and again, that's one where the crust, the continental crust, is in contact with oceanic crust, and there's no subduction going on at the moment. Eventually, that oceanic crust will get cold enough and dense enough that it will actually break away from the continental crust and begin subducting underneath it. When that happens, the continental margin transforms from a passive margin to an active margin. So what we have here is a passive margin, and it's a pretty good analogy to the eastern side of the United States. What we see is the shoreline there, where water laps up against the continental crust. And right beyond that, we have the continental shelf. Now, the continental shelf, like I said before, is actually an extension of the continents. The continental crust is still there. After that, we see a shelf slope break, and really that marks the edge of the continent, right? That's where the continental crust is ending, and you have the thinner, denser oceanic crust laying beneath the marine sediments that we talked about last week. After that slope, we have what's called the continental slope. After that shelf slope break, we have the continental slope, and the slope is a downward slope that is moving down towards the abyssal plain, which is the large flat area in the ocean. And after the slope, we have the continental rise. So you can see that we have this bending of marine sediments that follow the underwater topography of the crust as it transfers from continental crust to oceanic crust. All of that marine sediment fills in all of these extinct faults and any other type of rugged landscape to make the transition very smooth in most situations.